In this video, we are going to learn how to convert moles to number of particles, and we are also going to learn how to convert mass to number of particles and vice versa. Okay, so this way and that way to number of particles. Okay, so everything is balanced by moles, so we have to get through moles before we can go to the other side. So if we're given the mass, we use mass over molar mass to get moles, and then multiply the number of moles by Avogadro's number, or 6.02 times 10 to the 23. That is called Avogadro's number. Okay, so we'll use an example here, and we're going to use NaOH because we love NaOH. The first question here is how many number of particles are in 0.5 moles of NaOH. This is a statement that is true. 1 mole of any compound equal 6.02 times 10 to the 23rd power. Okay, so if I have 0.5 moles, that means that I'm going to have X here. 0.5 is half of 1. Then the number of particles would be half of 6.02 times 10 to the 23rd power. Okay, if we can do a simple ratio, we will have 1 mole times X equal 6.02 times 10 to the 23rd power times 0.5. Okay, so X will be 6.02 times 10 to the 23 by 0.5 divided by 1 mole, which gives us a cancellation of moles and moles, and we're left with the number of particles. In this case will be 3.01 times 10 to the 23rd power. And then the second one, now this one is a little bit involved because it takes 2 steps to get there, and I'll use dimensional analysis to illustrate this one. So this one is asking how many what is the number of particles in 15 grams of NaOH. So we set this up. Again, we start with what we're given, like what we're supposed to figure out. So we're supposed to figure out 15 grams of NaOH. How many particles are they? So we can multiply this by a fraction which equals 1. And this fraction that equals 1 in this case will be, again, remember, we need these units to be grams of NaOH, and we need the top units to be mole of NaOH. Okay, so 1 mole, what we know is 1 mole of NaOH equal 40.00 gram of NaOH. Okay, so when we do this, we can cancel out the grams of NaOH, but and only get moles. But this is not what the question has asked. The question has asked for the number of particles. So we have to do one more conversion. And that conversion should help us remove moles from this whole thing. So we should cancel out moles. So the units here should be moles, and here should be number of particles, which is just the number. So here we know that 1 mole equal 6.02 times 10 to the 23rd power. Okay, the grams of NaOH, the moles, the moles. So we are left with 15 over 40 times that big number. Question here. So we're given 2 significant figures. So this can be in 2 significant figures. It doesn't have to be 3. So this would be 2.3 times 10 to the 23rd power. Okay, so we did 2 steps. The first step was to calculate moles from mass. And then the second step was calculate number from moles. I will not use dimensional analysis for this one. I'll do it step by step, so that if you're the kind of student who prefers not to use dimensional analysis, this can help you. Okay, so I'm given 2.15 times 10 to the 23 particles, and I'm supposed to figure out how many moles, and then how much mass is in that. Okay, so this will equal X in moles, but what we know is 6.02 times 10 to the 23 particles equal 1 mole. X equal 2.15 times 10 to the 23rd multiplied by 1 mole divided by 6.02 times 10 to the 23rd. This will give us 0.357 moles. Okay, so this is the first step, convert to moles. And then in the second step, we are going to convert moles to grams. We know we are given 0.357 moles, and our job is to find the mass. And something else that we know is that 1 mole equals 40.00 grams. So what we're going to have here is our X will be 0.357 mole times 40.00 gram divided by 1 mole, which will equal 14.28, and the units that are remaining are grams. You can either do dimensional analysis where you just set it up, and I think it's easier to see and easier to follow. But if you are not a friend of dimensional analysis, do not worry. You can do it using the ratios, but you do it in 2 steps, if this makes more sense to you. However you want to do it, as long as you show your work clearly. Okay? If you make a mistake, a mathematical mistake, and you've shown your work clearly, it's easy for the person grading your work to see where you've messed up, and you can get partial credit. But if you do not show your work, then and your answer is wrong, then you just get 0.